Okay, hello everyone in a new video. In this one we are going to explain part 1 of chapter 3, which is the chapter of DC voltage and the second unit of electricity. So let's start. The figure of document 1 represents an electric circuit. What is meant by an electric circuit? So electric circuit consists of different electric components that are connected to each other by connecting wires. So what are the electric components in this electric circuit? So here we have the battery, and this is the switch, and here we have a lamp, and this is the motor. So these electric components, the four electric components, are connected to each other by connecting wires. So these are the connecting wires. So what's the role of each electric component in this electric circuit? Let's start by the battery. So the battery is an electric component that delivers electricity to other electric components. So here the battery is connected to the switch and to the lamp and to the motor, and the motor is connected back to the battery. Therefore, this battery will deliver an electric current, which is denoted by I. So the battery will deliver an electric current. So this is the electric current. Which is denoted by I. It will be delivered to the switch and to the lamp and to the motor and back to the battery. So this is the electric current I. Okay, how do we know the direction of the electric current? So notice that here the battery has a positive pole and a negative pole, and always the direction of the electric current inside a circuit is from the positive pole and back to the negative pole. Okay, and because the electric current I reaches the lamp and the motor, for this reason the lamp will glow and the motor will start to rotate. Okay, so now we come to the role of the switch. So here the switch is a closed switch. Now, because the switch is closed, we call this circuit to be a closed circuit. So the role of the switch is to close or open the electric circuit. Now, because here the switch is a closed switch, I repeat, the circuit is said to be a closed circuit, and for this reason the electric current I passes through the circuit. So now what happens if the switch is an open switch? Now in this case, in this electric circuit, the switch here is an open switch. And this circuit is said to be an open circuit. Now, because this circuit is an open circuit, so the battery is no more connected to the lamp nor to the motor. For this reason, the electric current I, which is delivered by the battery, will not reach the lamp and will not reach the motor. Therefore, the lamp will not glow and the motor will not rotate. So in this case, the value of the electric current I in this circuit is set to be 0. So the open switch doesn't allow an electric current to pass through, and this is independent of the position of the switch. Now suppose that we place the switch between the lamp and the motor. So in this case, the switch is an open switch, and this circuit is set to be an open circuit. So the lamp and the motor are not connected anymore, and the value of the electric current in this circuit will be 0. Similarly, if we place the switch now between the motor and the battery, so this switch is an open switch, and this circuit is set to be an open circuit because the switch is opened. And for this reason, the value of the electric current in this circuit is set to be 0. Okay. Now, moreover, here if you notice that in addition to the positive pole and the negative pole, the battery carries the following indication, which is 1.5 V So this quantity represents the voltage, which is denoted by U. So the voltage of the battery is given by 1.5 volts. V is the unit of the voltage. So U stands for voltage, and capital V stands for volts, which is the unit of voltage. So in this case, the battery is of 1.5 volts. So we can ask the following question: what's the voltage across the lamp? And what's the voltage across the motor? And as well as the voltage across the switch. So in this chapter we are going to learn how to calculate the voltages across different electric components as well as the current traversing the electric circuit. Then in order to do so, we are going to apply a well-known trick in physics, which is the same one we have applied in optics, which is drawing using symbols. Then let's give symbols for different electric components. So these are the electric components. The first electric component here is given by the battery. Then let's give it the following symbol. In order to distinguish between the positive pole and the negative pole, this is the positive pole and this is the negative pole. So the positive pole is the one which is larger and the negative pole is the smaller. Okay, now as for the connecting wire, the symbol of the connecting wire will be simply a line. Now as for the lamp, we will give it the following symbol. As for the motor, the letter M stands for motor. And now the close the switch. Will be similar to a connecting wire having two dots. Later we will see why. It has the same symbol of a connecting wire. And as for the open switch, we will give it the following symbol. Notice that each electric component here has two terminals. These are the two terminals of the battery. These are the two terminals of the connecting wire. These are the two terminals of the lamp, and so on. So each electric component has two terminals. Finally, before discussing the properties across each electric component, let's talk about the groupings of electric components. In the following electric circuit, we have the battery. This is the positive pole of the battery and this is the negative pole. And we have a lamp L1 and a lamp L2 connected to the battery. These are the terminals of the first lamp, and these are the terminals of the second lamp, which is denoted by L2, and the first lamp which is denoted by L1. So the lamp L1 and the L2 lamps L1 and L2 are in series. And this is because they only have one terminal in common. Then whenever two electric components only have one terminal in common, then they are said to be in series. For example, here the battery and the lamp has one terminal common, which is given by this terminal, say for example. Then the battery and the lamp L1 are said to be in series. The lamp L2 and also the battery are said to be in series because they have one terminal in common. The terminals of the battery are given by this and this. Now, as for the second electric circuit, which is on the right, here we have the battery. This is the positive pole of the battery. This is the negative pole. The battery is connected to two lamps, L1 and L2. These are the terminals of the lamp L1. And these are the terminals of the lamp L2. Then the lamps L1 and L2 are said to be in parallel. And this is because the two lamps have two terminals in common. So the first terminal of the lamp L1 is connected to the first terminal of the lamp L2, and the second terminal of the lamp L1 is also connected to the second terminal of the lamp 2. Therefore, the lamps L1 and L2 are said to be in parallel. Now, for example, if we connect here a lamp L3 to the lamp L2 like this, this is a lamp L3 connected to the lamp L2. Now the lamp L2 and L3 are said to be in parallel. Because they have two terminals in common. This is the first terminal of the lamp L2, which is connected to the first terminal of the lamp L3, and the second terminal of the lamp L2 is connected to the other terminal of the lamp L3. Therefore, the lamps L2 and L3 are in parallel. But now, we cannot say that the lamp L1 and L2 are in series. L1 and L2 are not in series, although the lamp L1 and L2 have one terminal in common, which is this. But notice that another terminal is connected, which is the terminal of the lamp L3. Okay, then we cannot say that the lamps L1 and L2 are in series. We only have that the lamp L2, L3 are in parallel, but still we have that the lamp L1 and the battery are in series because they have one terminal in common, which is this terminal. Then now we are ready to discuss the properties across different electric components. Let's start by the DC voltage. Then section 1, DC voltage. A constant electric voltage. Here the voltage is denoted by U. Let's consider a battery. So this is the symbol of a battery. These are the two terminals of the battery. This is the positive pole and this is the negative pole. Then the voltage is denoted by U. Now suppose that this battery has a voltage of value 12. Always all quantities in physics must have unit, and we know that the unit of the voltage is given by V, which is volts. And of constant value means that the value of the voltage, which is 12, it doesn't change, it remains the same when connected to the circuit. Such type of voltage is called DC voltage, and DC stands for D for current, direct, and C for current. Applied to a closed circuit. Now we all know what is meant by a closed circuit. Can send an electric current of constant value in one direction. Okay, so we have seen that whenever this battery is connected to a closed circuit, then it delivers electricity to other electric component, and this is done by the electric current, which is denoted by I. Now because the voltage here is of constant value, then the electric current I will be also of constant value and in one direction. We have seen that the direction of the electric current is from the positive pole to the negative pole inside a closed circuit. Now the common source of DC voltage is the battery. Then this is the battery. Now because this is the positive pole, let's give it a name which is P. P stands for positive. And as for the negative pole, let's give it another name, another letter, which is N. So this is the name of this terminal. Then the voltage of this battery is given by U equal to 12 volts. So now if we are measuring this voltage from the positive pole to the negative pole, so this voltage UPN is positive. UPN is equal to 12 volts. However, now if we are measuring the voltage from the negative pole to the positive pole, this will give us minus 12 volts. We always have that UPN is equal to minus UNP. Then whenever we switch these two letters, then UPN is equal to minus UNP. Therefore, whenever we are measuring the voltage from the positive pole to the negative pole, this voltage will be positive. This is as a general rule. And whenever we are measuring the voltage from the negative pole to the positive pole, this voltage will be negative. Then this is it for the battery or the DC voltage. Now the next thing that we'll discuss is the switch. And let me write down section number 2, the electric switch. Now we have seen that the electric switch or switch is an instrument or electric component which allows to open or close an electric circuit. Then the switch may be an open switch or a closed switch. Let's start by discussing the open switch. So 2.1 open switch. Then idea number 1, the symbol of the open switch. This is the symbol of an open switch. Now idea number 2 is that an open switch doesn't allow electric current to pass through. Now suppose here we have a battery. To the battery we connect an open switch like this. Here we have a lamp, and here we have a motor, and the motor is connected back to the negative pole of the battery. This is the positive pole and the negative pole. Now because here in this circuit the switch is open, so this is an open circuit, and therefore the electric current in this circuit is 0. An open switch doesn't allow electric current to pass through, so the value of the electric current in this case is 0. Notice that here I didn't place any unit for the value of I, and because it's 0, we know that 0 multiplied by anything will remain 0. For this reason, I didn't put here any unit for the 0 or for the I. Now idea number 3, an open switch in series with the battery has the same voltage of the battery. Now suppose that this battery is of 12 volts. Let's name this point to be the point P. This is to be N. This is A, B, C. Now we have that UPN is equal to 12 volt. We can ask the following question. Now we know the value of the current in the circuit. What's the value of the voltage UPA, that is across the switch. Here in number 3, they are telling me that an open switch in series with the battery has the same voltage of the battery. So here the open switch is in series with the battery because they have only one terminal in common, which is the point P. Then the open switch and the battery are in series, and then they have the same voltage because the voltage of the battery is given by UPN is equal to 12 volt. Then the voltage across the switch will be also 12 volt, and this is because the switch is open. Now idea number 4, that an open switch connected in parallel has the same voltage of its terminals. Okay, idea number 4, an open switch connected in parallel has the same voltage of its terminals. Now let's suppose here that we have a connecting wire. Then PA represents a connecting wire. In this case, the value of the current is not zero, so we have the current I, which is traversing the circuit and passing through all electric components. Now let's suppose that the voltage across the lamp is given by UAB is equal to 3 volts, and the voltage across the motor is given by UBC is equal to 9 volt. Later we will learn how to determine these values. And suppose here that we have an open switch like this. Okay. Now this open switch is in parallel with the lamp because these are the terminals of the open switch. Then the first terminal of the open switch is connected to the first terminal of the lamp, and the other terminal of the open switch is connected to the other terminal of the lamp, and therefore the open switch and the lamp are in parallel. Now they are telling me in idea number 4 that an open switch connected in parallel has the same voltage of its terminals. Now the terminals of the switch has the same voltage of the lamp, which is 3 volts. Then the voltage of the switch in this case is given by 3 volts. Now this is everything concerning an open switch. Now let's discuss the closed switch. Now idea number section 2.2, close the switch. The symbol of the closed switch is given by this. It's like the connecting wire having 2 dots. Idea number 2, close the switch allows electric current to pass through. Suppose here we have a battery. This is the positive pole and this is the negative pole. Here we have a lamp connected to the battery in series, and here we have a motor, and the other terminal of the motor is connected to the negative pole of the battery. Here we have a closed switch. Okay, this is the positive pole, this is the negative pole. Let's say that this is the point A, B and C. Now because this circuit is said to be a closed circuit, because the switch is a closed circuit, then the battery will deliver electricity to the lamp and to the motor. Therefore an electric current I will traverse the circuit. Okay, so idea number 2, a closed switch allows electric current to pass through. Now idea number 3 is that the voltage across a connecting wire is 0. Now across C and N we have a connecting wire. So UCN is equal to 0, and this is because the voltage across a connecting wire is 0. Now idea number 4, the voltage across a closed switch is 0 because it acts as a connecting wire. And now we can ask the following question: what's the voltage across the switch, across the terminals P and A? Now notice that this switch is a closed switch, therefore UPA is equal to 0, because the voltage across a closed switch is 0, and this is because the closed switch acts as a connecting wire, and we know that for a connecting wire the voltage is 0. Now it's convenient to solve some exercises as a direct application on what we have explained in order to check whether we have understood or not. Okay, exercise number 1. They are telling me consider the above electric circuit consisting of a dry cell of 12 volts and 3 lamps. Then the voltage of the battery is given by 12 volt, and because we are measuring the voltage from the positive pole to the negative pole. Okay, in number 1 they are telling me, are the lamps in series or in parallel? Notice that here the 3 lamps, they have only one terminal common. For this reason the 3 lamps are in series. And let's say since they only have one terminal in common, then the lamps are in series. Now in number 2 they are telling me when the switch K is open, what's the current traversing the circuit? We all know that an open switch doesn't allow electric current to pass through, and they are telling me what's the current traversing the circuit. In other words, they are asking me about the value of the current. Because an open switch doesn't allow electric current to pass through, then the value of the electric current, which is denoted by I, will be 0. Now in number 3 they are telling me when the switch K is open, what is the voltage across it? Notice that here the switch K is an open switch which is in series in the battery because they have one terminal common, and we know that whenever an open switch is in series with the battery, then it has the same voltage of the battery. Then let's say an open switch in series with the battery has the same voltage of the battery. Let's give this point to be, for example, say A. Then in this case UAN, which is the voltage across the open switch, is given by 12 volts, which is the same of the voltage of the battery. Now in number 4 they are telling me when the switch key is closed. We close the switch now. What is the voltage across it? Independent of the voltage of the battery, because we know that the voltage across a closed switch is 0, because it acts as a connecting wire. Now they are telling me what's the voltage across it, means that we need to give the value. This is the explanation. Then the voltage, which is across the closest switch, denoted by UAN, is equal to 0. Now this is it for exercise number 1. Let's move to the second exercise, which is exercise number 2. Okay, consider the above electric circuit consisting of a battery, a lamp, and a switch key. The voltage across the lamp is 6 volt. Then here the voltage UBC across the lamp is given by 6 volt. Okay, number 1, they are telling me what's the voltage UPA across the connecting wire PA, and we know that the voltage across the connecting wire is always 0. Let's write down the voltage. Across a connecting wire is 0. For this reason, UPA is equal to 0. Now they are telling me the switch key is open. What's the voltage across it? We know that an open switch has the same voltage of its terminals. Connected to its terminals, we have the lamp. The lamp has a voltage of 6 volts. Then the open switch has the same voltage of the lamp, which is 6 volt. Then let's write down an open switch connected in parallel has the same voltage of its terminals. For this reason, the voltage across the open switch, which is given by UVC, is equal to 6 volt. Now in number 3 they are telling me now K is closed. Let's close the switch. What's the voltage across the switch? We always know that the voltage across a closed switch is 0 because it acts as a connecting wire. In this case, the value of UVC is equal to 0 volts or 0. Then this is it for exercise number 2. Now let's move to the next section. Then section number 5, laws of voltages. Okay, section 5.1, law of addition of voltages. Now in this section we are going to discuss 2 different laws regarding the voltage. Here in this electric circuit we have the battery of voltage UG. This is the positive pole, this is the negative pole, and we have the lamps L1 and L2. The lamps L1 and L2 are in series and they are connected to the battery. Then the first thing that we must mention or notice is that the 2 lamps L1 and L2 are in series. And this is because they only have one terminal in common. Now we are mentioning that the two lamps L1 and L2 are in series because this law only applies whenever the lamps L1 and L2 are in series. Then according to the law of addition of voltages, the voltage of the battery, which is given by UG, is equal to the voltage across the lamp L1, which is given by U1, plus the voltage across the lamp 2, which is given by the voltage U2. Then from its name, the law of addition of voltages, addition, which means that always the voltage of the battery is equal to the sum of the voltages of the different electric components, which is given by the voltage U1 and the voltage U2. For example, here, if the voltage across the lamp L1 is given by 3 volts, then U1 is equal to 3 volts, and the voltage across the lamp L2 is given by U2 is equal to 6 volts. Then the voltage across the battery will be given by UG, which is equal to U1 plus U2, which is equal to 3 plus 6, which is equal to 9. Since U2 is in voltage and U1 is in voltage, then the value of UG will be in volts. So UG is equal to 9 volts. And whenever we need to use this law, we need to mention the law that we are using, which is law of addition of voltages. Always in physics, whenever we need to use the law, we need to mention the law. Usually we give half a mark for mentioning the law. Moreover, there is another version for this law, which is using the points. Now suppose that we name this point to be the point P, and this is the point A, this is the point B, and this is the point C, and this is the point N, which corresponds to the negative terminal of the battery. Now the other version of this law is given by, now we can say that apply law of addition of voltages, or according it's the same, apply law of addition of voltages, then always on the right we write the voltage of the battery which is given by UPN, and now on the right, so always on the left we write the voltage of the battery from the positive to the negative UPN, and on the right we will write the sum of the voltages of all electric components. So here we started with the point N, then on the right hand side we'll also start with the letter P, the letter that we have started with here. Now after P we have the point A, then UPA plus, then we have UAB, then from B we have the point C plus UBC, then finally from C we reach the point N. So notice that on the left we started with the point P, and on the right we started with the point P, and on the left we ended with the point N, and on the right we have ended also with the point N, and each letter we have inserted it twice. Here we have A, here we have A, here we have B, here we have B, and here we have C, here we have C. In this case, we make sure that the formula that we have written is correct. So these are two versions of law of addition of voltages. Later on, when solving the exercises, we will see when we will use this version or this version. Now here we can also say, or we can determine the voltage UPN of the battery. So now UPN is equal, now UPA is equal to 0, UPA is equal to 0 because across PA we have a connecting wire, and we know that the voltage across a connecting wire is 0, plus UAB, Across UAB we have the lamp L1, which has a voltage 3 volt, plus UBC. Now the voltage UBC is given by 6 volts, and across CN we have a connecting wire, and the voltage across the connecting wire is 0. Between the brackets we can write that UPA is equal to 0 and UCN is equal to 0, and the reason is connecting wires. And this will give me 9. Since UPA, UAB, UBC, UCN, all of them are in volts, then the value of UPN will be in volts. Then UPN is equal to 9 volts. Now the other law regarding the law of voltages is the law of uniqueness of voltages. Then here first let's notice that the lamp L1 and L2 are in parallel, and this is because this is the first terminal of the lamp L1, which is connected to the first terminal of the lamp L2, and the other terminal of the lamp L1 is connected to the other terminal of the lamp L2. Therefore the lamps L1 and L2 are in parallel. Then let's write down the two lamps L1 and L2 are in parallel. Now we need to mention the law. According to the law of uniqueness of voltages, they have the same voltage. Then whenever two electric components are in parallel, then they have the same voltage. And the word uniqueness means the same, or the same. Okay. Now suppose that the battery is of 12 volts. Notice that also the battery is in parallel with the lamp L1 and in parallel with the lamp L2, because these are the two terminals of the battery. So the first terminal is connected to the first terminal of the lamp L1, and the second terminal of the battery is connected to the second terminal of the lamp L1. Therefore the battery and the lamp L1 are in parallel, which means that the battery, the lamp L1 and the lamp L2 are in parallel. So this means that the voltage across L1 is 12 volt and the voltage across L2 is also 12 volt. Then in this case UG is equal to the voltage across the lamp L1, which is U1, equal to the voltage across the lamp L2, which is U2. So these are the two laws of voltages. Similar to these two laws, we have two laws concerning the electric currents. Then here first let's notice that the lamp L1 and L2 are in parallel. Now this circuit is said to be a closed circuit. Okay, so the battery, which is denoted by G, will deliver electricity to all electric components through the electric current I. Because this electric current I is delivered by the battery, then we call I to be the main current. Now this electric current I splits into two current, I1 and I2, such that I1 is the current traversing the lamp L1 and the current I2 is traversing the lamp L2. Then in this case, according to law of addition of currents, the main current I is equal to the current traversing the lamp L1, which is given by I1, plus the current traversing the lamp L2, which is given by I2. Now suppose that the value of I1 is given by 1. Now yet I didn't talk about the unit of the current. The unit of the current is given by ampere. So A stands for amperes. This is the SI unit of the current, and suppose that I2 is given by 2 amperes. Now in this case, what's the value of the main current I traversing the circuit? Then here for sure I need to mention that according to law of addition of currents. So let's write apply law of addition of currents. I repeat that they usually give half a mark for this statement, because always in physics we need to mention the law. Then I is given by I1 plus I2. The value of I1 is given by 1 and the value of I2 is given by 2. Let me change it. Let me make it here 3 and let me make it here 4. So this is 4 plus 3. This will give me 7. Since I1 is in amperes and I2 is in amperes, then the value of I will be in amperes. Then the value of I is given by 7 amperes in this case. So here the main current I splits into two currents such that the sum of these two currents will remain I. Here I1 and I2 will join back to give the main current, and this main current will reaches back the negative pole of the battery. And notice that always the direction of the current is from the positive pole to the negative pole. And finally, the final section in this video, which is section 6.2, law of uniqueness of current. Now here let's note that the lamps L1 and L2 are in series. Then according to law of uniqueness of currents, they have the same current. So here this circuit is said to be a closed circuit because all the components are connected to each other. This is the positive pole and this is the negative pole. Then the direction of the main current will be from the positive pole to the negative pole. So this is the current I1 traversing the lamp L1. Okay, and this is the current I2 traversing the lamp L2. So notice that the main current I is equal to the current I1, and the same current I1 will traverse the current I2, which is equal also to the main current that will reaches back the negative pole of the battery. Then in this case we have I is equal to I1 is equal to I2, and this is known as the law of uniqueness of currents. And I repeat, the word uniqueness means they are equal or the same. Now suppose that the main current delivered by the battery is given by say for example 4 amperes. Then according to law of uniqueness of current, the value of I1 traversing the lamp L1 will be given by 4 amperes, and the value of the current I2 traversing the lamp L2 will be given by 4 amperes, and the same for here. And by this we have finished the explanation of part 1. Now in the next part we'll complete the explanation of this chapter.